Agentic systems are emerging as the next frontier in generative AI applications. They consist of one or more AI agents that work together to accomplish tasks, changing their behavior based on human input and interactions with other agents. In the automotive industry, managing fleets of connected vehicles can be a challenge. As cars get more sophisticated and are increasingly integrated with internal and external systems, the volume of data they produce and receive greatly increases. This data needs to be stored, transferred, and consumed by various downstream applications to unlock new business opportunities. We believe that AI and machine learning will significantly impact fleet operations in the coming years. Optimizing route planning and improving driver safety are the two most common cited use cases. As fleet management software providers continue to invest in AI, the integration of agentic AI can significantly help with things like route optimization and driver safety enhancement. For example, AI agents can process real-time traffic updates and weather conditions to dynamically adjust routes, ensuring timely deliveries while advising drivers on their car condition. This proactive approach contrasts with traditional reactive methods, improving vehicle utilization and reducing operational and maintenance costs. We are showcasing how MongoDB can be leveraged to build an AI-powered connected fleet advisor. This application uses LLM to analyze driver complaints and fleet manager queries, generating diagnostic recommendations. In our multi-step diagnostic system, starting from the top left, a user submits an issue report, which the backend processes to trigger workflow. The system then uses an LLM to create a chain of thought and returns the results. Next, it retrieves the vehicle telemetry data. After that, we use the Voyage AI API to generate a complaint embedding and perform a vector search to identify similar past issues. Finally, the system combines relevant cases and telemetry data to offer a final recommendation to the driver. Throughout this process, MongoDB Atlas stores all of the data, ensuring traceability and enabling diagnostics to improve over time. Now, let's dive into the demo. First, we click on the New Diagnosis button to simulate a driver complaint. For example, a user notices a drop in oil pressure and a rise in the engine temperature. Once the agent receives the request, it runs it automatically. Alternatively, we can click the Run Agent button. This will connect the vehicle's data source, retrieving information such as its telemetry, fuel consumption, and temperature, and storing this information in MongoDB. Every time the agent runs, it creates a session. The agent generates a query embedding which runs in MongoDB vector search to retrieve historical reports and recommendations. Then it combines these results and sends them to the Cohere's LLM to generate a final recommendation. This demo outlines the entire agent workflow, including the agent run documents, chain of thought, and final recommendation, such as check the oil pump and lines for leaks or inspect the oil filter for blockages, helping to illustrate each step of the process. As for the agent information, we can view its profile, rules of engagement, and the telemetry data. Each diagnostic has a unique ID that lets you resume a session if an error occurs. To continue from where we left off, simply use the Resume Diagnosis button. So this demo highlights how MongoDB supports the creation of agentic applications to optimize manufacturing processes. With its seamless data integration capabilities, MongoDB simplifies the creation of these applications. If you want to learn more about how MongoDB is used in manufacturing and mobility, check out the resources below. Thank you so much for watching. Bye!